One other question I wanted to ask you is, in Greek mythology, there is this beast called a chimera. And as I understand it, it's got, I wish we had a picture, it was like the head of a lion and the body of a goat and the tail of a serpent, and a pretty ugly thing. But sometimes people use this same term, and they use a lot of Greek words, of course, in medical terminology, but they use the same term to describe vaccines that have been used in humans and also in animals, and I've heard the tag put on your vaccine as well. It sounds scary, but what does it mean?
It's actually pretty cool. Yeah. It's really innovative technology that we've been using. And what it really is it's taking the outer shell of the PCV virus from PCV2 and using the inner part of the virus from PCV1. And so having PCV1 and PCV2 together makes the chimera. But it actually is valuable to have PCV1, the inside of the virus, there. Okay. So let me explain that a little bit more. So most of the commercial vaccines only include the capsid, so only the PCV2 outside of the virus. And that's important because that's the immunodominant, or the part of the virus that the immune system recognizes the most. So it's important to have the capsid within your vaccine. But having the whole vaccine is it gives the pig a more authentic view, if you will, of the PCV2 virus. And so we have the PCV1 replicase, so the inside of the virus that allows it to replicate within our vaccine. And we've actually done some work to show that having PCV1 replicase can add to the coverage that we get from PCV2 field viruses.
So Meggan, you've made a great case for the Chimera technology, but there are these other porcine circle virus vaccines out there, and they're working pretty well. And they're based on what's called a baculovirus. How does a baculovirus vaccine differ from what Zoetis has put together?
So we grow our chimera, so the PCV1/2 chimera, in pig cells, actually. And the baculovirus is an expression system. So what they do is they take the baculovirus, which is an insect virus, and they engineer it to produce the PCV2 capsid.
Yeah, let me get this straight. So it's based on an insect virus, and that's what's going into the pig?
So it's mainly the PCV2A capsid, but of course when you make the vaccine, portions of that virus or portions of the insect cells that the virus is grown in, they do wind up in the vaccine.
So, I mean, it certainly sounds better if your vaccine is built on pig cells instead of insect cells, but practically speaking, what does that mean? Does that have a measurable benefit?
It could be that the pig, of course, is not exposed to these insect cells or the insect viruses. And so the immune response, the pig's immune system sees the insect cell or insect cell debris, and that can result in a costly energy response because the immune system takes energy.
And when you say a costly energy response, meaning specifically?
The pig uses energy to respond to the vaccine, and really everything that's in the vaccine. And so when we look at our vaccine, the pig responds to the PCV virus, and that immune response doesn't really recognize the pig cells that are part of the vaccine. On the other hand, for the baculovirus expressed vaccines, the pig also sees the PCV2A capsid, but it also sees some of that virus and some of the insect cell debris. And so that means that the pig's immune system is responding to some of that insect cell debris as well.
So it confuses it a bit, which then in turn saps the pig's energy, which maybe ultimately could compromise things like feed conversion or growth rate?
Potentially, but just as you said, those other vaccines work well too.
Well, Meggan, you've done a great job of kind of giving us a tour under the hood of the new vaccine and taking a very scientific subject and putting it in a language we can all understand, so I really appreciate it. We've been talking to Dr. Meggan Bandriick. She is a veterinarian and an immunologist at Zoetis. Again, Meggan, thank you for coming by.